Hi everyone, this is Robin DeMarco, onlinephysicsteacher.com. And today we're going to be looking at finding the length of a vector. Now, finding the length of a vector is something that every physics student must be able to do. It doesn't matter what we're doing. Whenever we calculate the displacement of an object or we look at the net force that's acting on it, we're going to need to be able to determine the length of that vector. Okay? So let's take a look at some two-dimensional series here. Let me share my screen and we can get going. So the way we're going to do this is very simple. We're going to use some trigonometry and basically draw this out. So what we've got here are two vectors, A and B, and let's just mark these down. We're going to say that A is a force of 4 newtons, and B is going to be a force acting at the same time on the same object, but at 90 degrees from A. And so B is a force now of 3 newtons. Okay? Now, the way this is going to work is it's pretty simple, actually. We're going to do some addition of the vectors. So I'm going to take and choose vector B here. Why is it? There we go. We're going to copy it, and I'm going to, oops, close that. We're going to paste it. There we are. And we're going to move it right here at the tip of vector A. Now, this is known as the tip-to-tail method of addition for vectors. We've just basically taken the two. We put one down in the plane that's already in. We put the other one so its tail is at the tip of the first one. That's all. And in this case, the resultant vector, I'll make that in red, is going to be a line that's going to run from the origin to the tip of the last vector. And like I said, this, we're going to, oops, let me move my pen there. And that is vector R. Okay? Now, we can use some simple algebra. Like I said, trigonometry and Pythagorean's theorem tells us that we can find this vector here. Okay, it's a right triangle, right? So we really got C is equal to the square root of A squared plus B squared. Now, putting that in the terms we've got here, my resultant vector then will be equal to the square root of vector A squared plus vector B squared. And putting our numbers in, we've got what we've got here now is we have 4 newtons squared plus 3 newtons squared. And we're taking the square root of everything that's there. And so we see that this is going to work out to giving us 16 newtons squared plus 9 newtons squared, or the square root of 25 newtons squared, which is really just 5 newtons. Okay, and that is our resultant vector for this particular point. So in a two-dimensional system, the length of this vector would work out to be 5. But what happens now if we find ourselves dealing in a three-dimensional system? So let me do that. Now we've got the same basic system. We've got A and B are still here, our two vectors. And we're going to keep the same values on these. So again, we've got a 4 Newton vector here. We've got our 3 Newton vector over here. But we've added in this new part, this new one, C. And that is our new vector. So let me talk about that one. First of all, we notice that C is acting on the Z-axis here. All right. And it's going backwards. So this one is going to have a value, let's say, of minus 6 newtons. Didn't quite get the, you know what, I'm going to move that. Oops. out of the way. There we go. Okay, so we've got these three parts here. And again, I'm going to go to red for my vector part here. But again, what we're going to do is we're going to start off with moving things around a little bit. Okay, so again, we're going to copy and paste our first vector, which goes here. But now we're also going to take and copy vector C. I did it again. Hit Control B instead of Control V. There we go. And so this is going to go on here like this. Now, right now, this is a little hard to look at. So let me draw a few other lines in here in a different color that'll help us see this. I'm going to try a light green. I tried it with a yellow, and I didn't like the way it looked. So we'll try it with a light green here. Okay. What we've got, first off, if we take and we draw a rectangle here. Okay, there's our first one. And just because I want to make sure everything stays the same, I'm going to take and just copy that rectangle. There's another one. Okay, and we're going to put that back here. There we go. All right, now it's just a matter of taking and putting some lines in here to kind of fill in the gaps. Oops. Forgot to put. There we go. And I think I am going to move this particular, oops. I'll move this one here out just a little bit so we can. I want to put the orange one on the top, just so it stands out a little bit better. Although it's not going to let me do that. Okay, well, we see the orange one hiding back here, so we just know we've got to go there. So our resultant vector then is going to go from the origin to that corner. Now, it may seem counterintuitive right away, but really this is nothing new. All right. Now let me explain what I mean by that. We know, and I'm going to change my pen color here. We'll use a nice purple here. We know that the resultant vector that goes between A and B, so this one right here to that corner, is a certain length. And if we look, we've got another triangle here. It goes up here, over, and there's the hypotenuse. Okay, so I can really do this in a couple of steps here. So let's do that. Go to a different pen color here that we actually can see better. All right, so I'm going to just take a quick look here at the resultant vector. Oops. Forgot to go to my pen. There we go. So the resultant vector, and I'm going to label this as purple. We already know is the square root of a squared plus b squared. We did that in the last set, if you remember. Okay, so we already have that as a piece of knowledge that we can deal with. Okay. Now, if we look at the next part here, we take a look at this particular triangle. Okay, and I'll see if I can kind of trace it out here and draw it for you. Here to there and there. That's the triangle I'm looking at now. And that gives me the new resultant vector R that we talked about. That's the red line. And so R is going to be the square root of our purple squared plus this vector here, which we said was C. Okay, I know our purple is a squared plus b squared, and I have to square that. Well, is going to get rid of my square root sign. So I just have a squared plus b squared plus c squared. Almost too easy, isn't it? Okay, so going back to our example here, we've got the 4 Newton force for A, 3 Newton force for B, and a minus 6 Newton force for C. We can substitute all these in, and we get our 4 Newton squared plus 3 Newton squared plus the minus 6 Newton squared. So we've got 16 Newton squared plus 9 Newton squared plus 36 Newton squared. And we add all this up, it's going to come out to the square root of 61 Newton squared. And therefore, in this case, our resultant vector R is going to be 7. I think it's 7.8 newtons. Okay, so I hope that helps you out a little bit. And the next time you have to find the length of a vector, you don't panic about it. It's really not going to be that big of an issue. If you found the video helpful, please give me a thumbs up. If you liked it, hit the subscribe button down below, and you can be notified the next time we have a new video coming out. So I hope that helps everybody. Take care. Oops.